Hey guys, welcome back to the RC Science Geek. It's me, Kiel. Today we are at part 2 of the build impressions for the RES Wiki, an F3L competition class glider from Tomáš Hlavinka from Czech Republic. Today we're gonna talk about the elevator, rudder and the fuselage, some problems that I bumped into with my servos and the battery. Gonna get some build tips, how to find your pieces. But before getting into detail, I have to make some corrections. This is regarding this piece. This is the tail mount. I said this is for the rudder, but it's actually for the elevator. So next thing, we should talk about regulations, because in the discussions on RC Network and on RC groups, there were some comments about pieces included in the kit. And these are mainly the servo mounts, the hook, and again the tail mount for the elevator. These are actually prohibited by the regulations for the F3L class. I think you should go without them. Servo mounts are not really a big issue. You just put some buzzer on each side of the servo and it fits tightly and squeezes them in. Tail mount is also easy to replace, just use some birch ply. And the tail hook is actually something where you can save some weight. It's right below the CG, so no issues with that. So build tips. First thing first, this is no kit for starters. Second tip is, if you're looking for your pieces, just stick to the numbers, stick to the range. This rudder is mainly the numbers from 10 to 20 or something around. So if you take out all these, you're ready to go. And as you can see, this plan is still not covered for the rudder and for the elevator. You don't really need a plan to build it. You just have to figure out where you have a well-aligned corner where you can start off. So if we talk about gliders, especially thermal gliders like these F3L, F5L class, it's always a big issue. What's the weight? What's the wing load? So you want to be light. So it's actually very easy to achieve the weights that are mentioned in the build kit. My rudder, including the fin, is 5.5 grams and the elevator is 9.5 grams. Although I have this carbon fiber rod in there, nice selection of wood, so it's no problems there to achieve the weight. Speaking of this extra carbon rod, I really believe it pays off. Bending is reduced by around 50%. I made a very basic bend test and it showed a great improvement in the strength. This is just a simple 1.5 millimeter carbon rod glued in there. So I send it out like this channel where I can put this rod in and it adds 1 gram of weight, but it gives really some extra strength. It's really nice. One thing that you might bump into is that my fit was sometimes a bit loose, so I ended up putting some wedges in these corners, so I have the full strength of these connections. So the tail is covered. Now let's get to this little beauty, which is the basic inner construction of the fuselage. I have to admit, this was a bit mind-wrecking. I show you in a minute why. But first, building this is not a big issue. You have to prepare some compounds before, like this very thick rib that's made out of 3 pieces of balsa. And then for the wing joiner, you have some birch ply rings, like 8 pieces, I think. Have a look on the fit. If everything fits well and goes in and out nicely, you can start gluing the pieces together. What I also would suggest is, before you put this final sidewall on the other construction, you already mount the hook in the fuselage. And I also have already glued in the tubes for the push rods. Now let's discuss battery and servos, because before you close or put a glue on the final sidewall, you should also think about your choice of servos and the battery. There's not much room. Tomáš suggests to have servos like the KST-08 or something similar, and I know why now. Some people use things like these. Tau Pro SG90, very basic servos, cost like €5 or something like that, or a glider that doesn't go fast. Why not use a cheap servo? but in terms of space, you actually have no chance in fitting this in there. These are AMAX 3352. They are 8mm thick, so you think this would fit? No, it doesn't. Maybe I could squeeze it in there somehow. I don't want to destroy this servo. I still need it. So let's turn to the next one. On the first pictures that I saw him using these very nice Bluebird BMS 125 or similar servos. They go in there, so it's no big issue. But if I turn this around, we'll see that the servo horn is actually looking out. The most inner hole actually is just a millimeter below the inner surface of the sidewall. For my personal taste, it's actually too tight in there. So now I have these tiny little critters. These are fitting the bill, but still, I think it would be nice to have like 4mm more of space to fit in any servo that you want, and you feel much more comfortable mounting all the stuff. As you can see, I cut through the whole fuselage from one side to the other. I even cracked this out, this piece, but in terms of strength, you don't need that. I mean, like, this happened by accident because I wanted to fit in this 2S lipo as my battery, and it's just a tiny excess thicker than 10mm, and I had no chance getting this in there. So I tried to sand this out on both sides, and then in a sudden moment it just cracked out, and I thought, let's throw this. Now the battery completely fits in here to the front. It's well stuck in there in the nose. One suggestion is definitely to think of your equipment and the mounting before you put the final cover on, because then it's still much easier to sand off like 1mm, 2mm on each side. You have a much easier time than me. I did this after the whole fuselage was put together. Two final suggestions that I have is, like, these servos are not mounted the same. This is an idea from RES Wiki, a website from Germany. This one is actually tilted by an angle. So this way the servos don't align this in the same direction. And this gives you space between the two push rods then in the final mounting. Last suggestion, as you can see, this is still not covered. In the original version, you have this 0.8mm of birch ply that goes on each side of the fuselage. This is nice because it gives you a hard shell, but I don't really think that's required. It's actually up to you what you want to use as a cover. This piece of 0.8 birch ply has like around 12.5 grams. So on each side you put this is like 25 grams. If you replace this one with 0.4 millimeters of birch ply, then you already have like an advantage of 6 grams on each side, so 12 grams in total. I'm going for 3mm, a bit sturdy balsa. It has the same weight as the 0.4 birch ply, but I can give it a more rounded shape. That's the idea. These two give you a weight advantage. The question is definitely CG somewhere here, so you're making the this bird lighter in the front. Does it really pay off actually or not? Do we have to put in some additional lead to get the CG right or not? So well guys, this is the progress of my wiki for the moment. I already saw some finished gliders in Sweden, and I know some kids are going to Australia. So good luck for you guys in Down Under. So in part 3, I hope to be back with the ready-made fuselage and the main wing. So see you next time. Bye.